Hello, 6th grade. This is the Diablo Spicy report for the transfer of energy reading. If you are on the wrong video, figure it out. Switch videos, grab the Diablo Spicy reading. Just make sure you have your name, class, and date, and let's get started. Diablo Spicy, a report on the transfer of energy. Energy is involved in nearly everything we do. It is defined as the ability to cause change, to set an object in motion. There are several different kinds of energy. Kinetic energy is the energy an object has when it is in motion. Vibration, forward motion, turning, and spinning are all examples of kinetic energy. Kinetic energy is directly proportional to the mass of the object. If two objects move at the same speed and one has twice the mass of the other, the object with twice the mass will have twice the kinetic energy. Questions. What is the definition of energy? And the next question is, how does mass affect kinetic energy? If you do not know the answers to these questions, you didn't get it from the reading, maybe go down to hot medium. It's okay to explore other readings, but we are going to move on. If you don't have these answered, pause this recording and rewind. Next page. Potential energy is the energy an object has because of its position. It is energy waiting to be released. For example, a weight suspended above the ground has potential energy because it can be set in motion by gravity. Compressed or extended springs also have potential energy. Thermal energy is the kinetic energy of atoms vibrating within matter. The faster the atoms move, the hotter the object becomes. Electrical energy is the kinetic energy resulting from the motion of electrons within any object that conducts electricity. Chemical energy is the potential energy stored in molecules. Thermal, electrical, and chemical energy are all forms of kinetic or potential energy. Questions. What is potential energy? Next question. Why is thermal energy a form of kinetic energy? Next question. Why is chemical energy a form of potential energy? Okay, we are moving on. If you need to rewind, feel free to rewind or pause. What laws control energy? One of the most fundamental laws of physics is that energy cannot be created or destroyed, only transformed from one form into another. For example, if a suspended weight falls, its potential energy becomes kinetic energy. This law is called the law of conservation of energy. Energy can also be transferred from one object to another. Think about a game of bowling. When a bowling ball hits the pins, the moving ball stops or slows down, and the pins begin to move. The majority of the bowling ball's kinetic energy has been transferred to the bowling pins, while a small amount has been converted to thermal energy by the collision. If you could measure the temperature on the surface of each bowling pin, you would find there was a slight rise in temperature at the point of contact. The total amount of energy involved, kinetic and thermal, remains the same. No energy was created or destroyed by the collision. Questions. Make sure to use the reading to help you. The law of conservation of energy says that. Next question. Draw a tiny picture of you bowling. What happens to the kinetic energy in the bowling ball when it hits the pins? Draw a tiny picture of you sledding down a hill. Where do you have the most potential energy? And what happens to your potential energy as you slide down the hill? All right, last page. Who wrote these laws? English mathematician and physicist Isaac Newton, 1642 to 1727 is when he lived, wrote the law of conservation of energy, and many people think he did all the work behind it. However, many people before him studied gravity and energy. In the future, you might be asked who discovered gravity or who discovered gravitational energy. they will expect you to say Isaac Newton, likely, but this random white dude from England didn't just stumble on how gravity and energy work. Okay, and I do not speak these languages that are coming up, so just bear with me here. Indian mathematician and astronomer Aryabhata, 476 to 550, first identified the force which explains why the Earth's rotation does not cause objects to spin away from it. Indian astronomer and mathematician Brahmagupta, circa 598 to about 668, described gravity as an attractive force and used the term Gurutvakarsanam to describe it. This inspired other people to study gravity. The law of conservation of energy didn't emerge until later. Ancient philosophers as far back as Thales of Miletus, about 550 BCE, so before Christ, had inklings of the conservation of some underlying substance of which everything is made. Although energy does not make things, it gave the idea of energy being conserved to other scientists. In 1639, philosopher Galileo published his analysis of several situations, including the celebrated interrupted pendulum, which can be described in the modern language as converting potential energy to kinetic energy and back again. Essentially, he pointed out that the height of a moving object rises is equal to the height from which it falls. Emile du Châtelet, 1706 to 1749, proposed and tested the hypothesis of the conservation of total energy. She repeated an experiment where balls dropped from different heights into a sheet of soft clay. Each ball's kinetic energy, as shown by the amount of clay moved, was shown to be equal to the initial potential energy. On this basis, Châtelet proposed energy is transferred from one form to another without losing energy along the way. In short, many scientists contributed experiments to support modern theories of energy. It is also worth remembering the scientists who do not receive credit for their work, including a plethora of women and people of color. Scientists all over the world have been working on these theories for millennia or thousands of years. That is the end of the recording. I don't